Okay. Are there any questions before we get started? Can someone please confirm you can hear me?
We can hear you.
Great. My apologies for being a bit late. They have a new procedure for logging in and I have to verify my existence and I forgot about that new procedure. Let me share my screen. Let me go to where we are. Oh, that's the wrong button. Close that down. Oh, shoot. Having trouble sharing my screen here for some reason. There we go. Today is February 22nd, and we're doing Lab 8, Identification of Gram-Positive Organisms. Please let me remind you, your infectious disease paper is due at 11:59 p.m. this Saturday. Any questions about any of that? If not, let's go on to Lab 8. Lab 8 is going to be identifying gram-positive organisms. We're going to look at both gram-positive cocci and gram-positive bacilli. Of the cocci, we're going to cover Staphylococcus, Enterococcus, and the Streptococcus families. For the gram-positive bacilli, we're going to cover Listeria, Clostridium, Corynebacterium, and Bacillus. There are some video clips in today's lab. You will be working with the dichotomous key, and there are a bunch of case studies in this lab. Any question about any of these? All right, upon finishing this lab, your learning objectives are: 1, understand the principles and how to interpret the results for the CAMP test, the bioesculin auger slant, the SF broth test, and the optogen sensitivity test. We're going to use a dichotomous key to solve case studies involving gram-positive bacterial infections. Any questions about our learning objectives? If not, when specimens are received in a microbiology lab for routine bacterial culture, they're inoculated on culture media that will facilitate the growth of common pathogens and placed in physical environments to support their growth. Microbiologists do use colony morphology and the gram stains to provide important information in the classification of bacteria isolates. However, you cannot classify it on this information alone. Further biochemical testing is required. In this lab, we're going to discuss the CAMP test, the bioesculin hydrolysis test, the SF broth test, and the optogen sensitivity test. The CAMP test is named after the microbiologist's name, meaning it's an acronym for Christie, Atkins, and Munch-Peterson, C-A-M-P, CAMP, who first described the amplified hemolytic effect that some beta hemolytic organisms have when they're physically grown near Staphylococcus aureus. The single streak of beta hemolytic Staphylococcus aureus is placed down the middle of a blood agar plate. Perpendicular to the staphylococcal streak, another streak is made with the test or unknown organism. So here, let me blow this up. Here is the streak of Staphylococcus aureus, and it's, I don't know, a yellowish, orangish streak. And then around that is a clear region of beta hemolysis that Staphylococcus aureus makes. Let me blow this way up because Streptococcus pyogenes is really thin streak. Right there, you can see the Streptococcus pyogenes streak, and it too has a clear region of beta hemolysis around it. in the CAMP test, we're looking at this region here to see if there is enhanced hemolysis near the Staphylococcus aureus. And with Streptococcus pyogenes, there is no enhanced hemolysis. So that we'd say is CAMP negative, which is shown there. With Listeria, we have a slightly positive CAMP reaction. Let me blow this up. So once again, the Staphylococcus aureus, and it's much clearer in this picture than that one. And the clear region being the beta hemolysis around the Staphylococcus aureus. With the Listeria, let me blow this way up. You can see the streak here, and it has a real thin line of beta hemolysis around the streak. And near the Staphylococcus aureus, we see enhanced hemolysis. But it's slight, and I'll show you what major hemolysis looks like. There's major hemolysis shown by Streptococcus lactea. And there's the streak there, and it's showing beta hemolysis there, which is pretty small. And then right here, we have in greatly enhanced hemolytic activity. And you'll notice that that CAMP reaction tends to look like an arrow. There's the, I don't know, what do you call it, the wood of the arrow, and then there's the arrow point, very clear arrow point. Even with Listeria, meaning the slight CAMP reaction, we do have an arrow type shape. And I don't know why it takes a arrow type shape, okay? But the hemolysis is more enhanced further away from the Staphylococcus aureus than it is near the Staphylococcus aureus, taking on the arrow shape. Any questions about the CAMP test? So CAMP is used largely with the Streptococcus family, looking at enhanced hemolysis around Staphylococcus aureus, but it can be used with other bacteria. Listeria is not of Staphylococcus, Streptococcus family, sorry. And it is used on only beta hemolytic bacteria. All right, let's move on to the bile esculin hydrolysis test. This media has esculin in it, and if the bacteria can hydrolyze it, it'll make esculatin, which is a dark brown in color, which when put all together tends to look black, but it may just look a dark brown. This test is used to differentiate Enterococcus from Streptococcus. So this is a family and that's a family. And the Streptococcus are negative in the bile esculin hydrolysis test. And the Enterococcus species are positive. To be positive, you're supposed to have 50% or more of the tube darkening. And then negative is less than 50%. Usually negative is no change in the color of the tube. All right, let's move on to the SF broth test. The SF broth test gets its name from an old species name that we no longer call it this, but the old species name was Streptococcus faecalis. And it used to be called that because they thought it was a Streptococcus or a member of that family. But when they, I don't know, sequenced the DNA, they discovered it is not a member of the Streptococcus family, and they made it its own family, the Enterococcus. And so its new name is Enterococcus faecalis. Well, even though the new name is Enterococcus faecalis, we do not change the name of the test. It's still called the SF broth test for the old name Streptococcus faecalis, which is no longer correct. It should be Enterococcus faecalis. And we'll just usually call it the SF broth test, and hopefully that won't confuse you on why it's called that. In the SF broth test, it has a media, liquid media, which is purplish in color. And when you have bacteria which ferment the sugar galactose, meaning galactose is in the media, it will produce acids and change the color from a purple color to a pale yellow color. So this is SF broth test positive, and this is SF broth test negative, where the color doesn't change. Remember that when glucose is fermented, it does produce acids, and that changes the indicator to a yellow color. This test is used to separate Enterococcus from Streptococcus species, meaning those two families. Streptococcus species are negative in the SF broth test, and then the Enterococcus families are positive, specifically Enterococcus faecalis. Any question about the SF broth test? All right, let's move on to the optogen sensitivity test. The optogen sensitivity test is used to differentiate Streptococcus pneumoniae from other alpha hemolytic streptococci. So we don't usually run this test unless we know that the species is a member of the streptococci family and it has alpha hemolytic activity on a blood agar plate. And then we run this test to separate out Streptococcus pneumoniae from the other members of the Streptococcus family, which cause alpha hemolysis. So here we have a blood agar plate, and if I can blow that up a little more, you can see that it's showing darkening around the bacteria. I'm not sure why the colonies are, they almost look like two colonies together, but they're growing not roundish, they're kind of oblong. And I don't know why that's the case, but there is darkening around the colonies, so they are alpha hemolytic. And for some reason, we know it's of the family, excuse me, of the family Streptococci. And then you take the bacteria and you smear it on this region of the blood agar plate. You could smear it everywhere, but you just need to smear it in this region of the plate. And then you put on the disc containing the antibiotic Optogen. If the bacteria are resistant to the Optogen, and that means that they have a zone of inhibition less than 14 millimeters. In this case, we have less than 14 millimeters, and there's no zone of inhibition. So this one we know is an alpha streptococcus member of the Streptococcus family, but it's not Streptococcus pneumoniae, because Streptococcus pneumoniae is sensitive to Optogen, and the zone of inhibition will be 14 millimeters or greater. Any question about any of that? And you can note that they should have extended this out a little ways because the zone of inhibition goes beyond the circle of the bacteria or the square of the bacteria. All right, any questions about the Optogen sensitivity test? If not, let's talk a little bit more about dichotomous keys. They are used to help individuals identify a species. The dichotomous key in this lab should only be used with this lab. Do not use it or any other dichotomous key in a lab in your unknown project. Only use it for the dichotomous key for this lab only. The dichotomous key uses a logical solution where a methodical thought process is used, and you start with all possible organisms, and then you run one test, such as the gram stain, separating the bacteria into gram-positive and gram-negative organisms. Once you get the answer, you scratch out the gram reaction, which is not applicable. And so we have gram-positive cells. And then we run another test to separate the bacteria into two possibilities, such as gram-positive bacillus and gram-positive cocci. So that test is then ran, and you scratch out the gram-positive bacillus because the shape isn't a bacillus, it's a cocci. You then, following dichotomous logic, run another test, and we're going to run the catalase test, and that can separate it in catalase positive species, which are, in this case, members of the Staphylococcus family, and then the catalase negative individuals, which are members of the Streptococcus and the Enterococcus families, meaning all gram-positive cocci in this test, if they're catalase negative, will be Streptococcus or Enterococcus. We then scratch out the catalase negative because the bacteria are catalase positive. And then we do another test, the coagulase test, separating the bacteria into coagulase positive and coagulase negative. If it's coagulase positive, the bacteria is Staphylococcus aureus. And if it's coagulase negative, it's another member of the Staphylococcus species, which is not Staphylococcus aureus. And it's not Staphylococcus aureus, or meaning not coagulase positive. So we take the Staphylococcus negative, and then we run another test, the novobiocin test, separating the individuals into novobiocin positive and novobiocin negative. The novobiocin negative Staphylococcus or Staphylococcus cephrophyticus, and then the novobiocin positive Staphylococcus, in this case, is Staphylococcus epidermidis. Any question about doing an unknown test on an unknown species and then using dichotomous logic to get your answer? On this
I
case,
actually have a question. So if you scroll up, I believe it was like the lactase test or something that was up above the coagulase test. Underneath the negative side, it says it's either Streptococcus or Enterococcus, but there's no other tests below it.
where
What
are you
happens
talking about? Right here?
at the catalase?
Catalase.
The negative side, there's two options, but there's no other tests underneath it. So what
That's
happens
because
when
we're
that?
scratching this out and we're following this one. That's why there's no further tree developed on the negative here. Okay? But on the dichotomous key for this lab, there probably is further tests under the negative. Okay? But for here, we're not going further because it's not catalase negative. We're following the catalase positive organisms. Okay?
Okay, yeah, I get it.
All right. I'll show you the dichotomous key in a little bit, but not now. I want to finish what we're talking about here. So in lab 8, you're not going to be performing any of these activities. Everything is going to be done online. However, you will be held responsible for knowing how to perform and interpret these tests. The following video clips go through the SF broth test and the bile-esculin hydrolysis test. We have another video clip discussing the CAMP test. So watch these two videos. They're short videos. And then review how to interpret the following tests by completing the chart. And don't complete the chart here. Complete the chart in the worksheet for Laboratory 8. The first member of the table has been filled in here. It's explaining to you that for the gram stain for cocci and bacilli, if you have a positive result, the color is purple. If it's a negative result, the color is pink. So go ahead and fill this in for the Schaefer-Fulton stain for endospores. Give the positive result and the negative result. And to complete this table, some of the information will come from this lab, meaning the CAMP test, the biosculin test, the SF broth test, the optogen sensitivity test, all come from this lab. But some of the information you'll have to look up in a previous lab, such as the Schaefer-Fulton stain for endospores, the negative stain for capsules, the catalase test. This one was in the last lab. The coagulase test, I don't remember if that was in the last lab or not. And the oxidase test. These have to be pulled up for the reaction, the positive result and the negative result from a previous lab. And then I put in here basic trace and sensitivity test, and I've made it optional. You can do it if you want or not. The reason why I put it in here is that some of the case studies in this lab involve the basic trace and sensitivity test. And so I'm trying to give you a reminder of what the positive result and the negative result looks like. You will not get extra credit if you put in the information, and you do not need to put in the information. It is optional. In the future, I'll probably make it required, but at the moment it is optional. And it's just to help you for identifying 2 of the case studies that you're doing today. Any question about that? So fill in the table. And then for number 3, this is a video and a link to help you work on a dichotomous key. If you're having trouble understanding the concept of a dichotomous key and how to use a dichotomous key, click this link. If you're perfectly comfortable using a dichotomous key and understanding a dichotomous key, you do not need to do anything in number 3. And if you'll notice, there is no question here, so there's nothing that needs to be filled in. Okay? I had a student ask me, where's the question to number 3? There is no question, okay? It's just there for your benefit. These species of bacteria in number 3 are the species that we'll be working with in the case studies. And then in number 4, read through the case studies, do the case study, and then put the answer for what species is causing the infection in the case studies here. So for case study 1, put the species that you think is causing it there. In case study 2 and case study 3, it has a test 2 in it, and I'm telling you in here that test 2 is the basic trace and sensitivity test. And so you have to know how to interpret the basic trace and sensitivity test to get the information for solving case study 2 and case study 3. All right, any questions about that? Now, where are the case studies? They're the same place where the, let's close that down. Come back home. They're in lab 8, right underneath lab 8. So there's the module for lab 8, the worksheet for lab 8. Remember, only submit the worksheet. And you have to go here to submit it. So I don't know why that doesn't remind people only to submit the worksheet. Here are the case studies. The instructor I got it from, the lead instructor of microbiology, sent it out in a bunch of individual files. And I thought about putting it all together in one file, but then if the instructor changes one file, he'll only send me case study 2, for example, and then I would have to redo everything. So I decided to keep it as individual 8 files. And it is true that at one time he did switch, I think he switched to 2 or 3 of them. So I did have to change them. Anyways, you got to click on each of the case studies to get it. And then for solving it, pick up the dichotomous key. So click on the dichotomous key. I'm not going to show it here. I'm going to get it here because it'll display better here. It won't display good in Canvas. All right, so the dichotomous key follows the gram-positive bacteria. We split them first into cocci and bacilli. For the gram-positive cocci, we then split them into catalase positive and catalase negative. If we're crossing out the catalase negative, you then do the coagulase test for the catalase positive. Note if you're not doing the catalase positive, you're following the catalase negative, it looks like we're doing the, it's not stated here, but this is the hemolysis test for alpha hemolysis, beta hemolysis, and gamma hemolysis. Okay? And I'm not going to go through all of them, but for the gamma hemolysis, we then do the bile esculin and SF broth test. And for some reason, we're doing those 2 tests together. That's not usually dichotomous logic when you're doing 2 tests at once. But in this key, that's the way you do it. For all of the others, come on. For all of the other tests, you only do 1 test. For following the gram-positive bacilli, you need to go to page 2. And that follows the gram-positive bacilli. We then separate them into anaerobes and the aerobes. We then, if it's an aerobe, split it into the bacillus species and the listeria and the corynebacterium species. And that's based on endospore production. All right, any question about any of that? It looks like on this one here, we're not going down to the species that they're stopping once you get to the family Clostridium. And also they're stopping when they get to the family Bacillus. And actually all of these are stopping at a, well, that one's stopping at a family. That is not. That is a species. Okay, any questions about any of that? All right, so go through each case study. I'll start the case studies. I don't think I'll do all of the case studies. But in case study 1, we have a 13-year-old teenager who attends a summer camp. Upon returning home, his mother notices a pustule beginning to develop on his arm, and it looks like a spider bite. It's warm to the touch and is becoming extremely painful. When her son starts running a fever, she takes him to a medical clinic for evaluation. The physician orders a gram stain, and you have to blow this up to see that well. I can't do that. Let me blow this up. And now I can do it. Up too far. There's the bacteria here. And these cells are not bacteria. Those are the boy's cells. Okay. So they didn't subculture this on a what do you call that? A petri dish. What they did was they actually sampled the wound and got bacteria in it. All right, how do I shrink this? There we go. They then took these cells and grew it on a blood agar plate, and you can see the hemolysis going on here. And so write what the cells are, the shape, anything else about them, and then what the hemolytic activity is on the blood agar plate. They then run the catalase test, and there's the results there. So write down your result. And then they did one further test. They grew the bacteria on mannitol salt agar plate. And so you have to look up what this means. You can look up in your unknown project. I've got the mannitol salt agar on there. And This is the normal color of the mannitol salt agar plate. And when you streak the bacteria here, you can see it changes the color. All right. And then what bacteria was isolated? Write it down in your worksheet for this lab. Let's see. Let's go to case study 2. A 27-year-old female goes in for prenatal care. The OB/GYN physician orders a routine vaginal culture. The patient is not exhibiting any signs or symptoms. The Thayer mountain tube has no growth, but lactobacillus and normal vaginal microbes were cultivated on BAP. However, several colonies of interest were subcultured on BLAP, and here's one of them here. You can see the hemolytic activity there. And then they did a gram stain on that. You got to blow that up to see that properly. Try and determine the shape as well as the gram stain. All right, that you can make out what it is. Let me shrink that down now. And then they take the bacteria here and do the catalase test. There's the results of the catalase test. They then do test 2, and that's the bacitracin sensitivity test. Make sure that's right. Yep, bacitracin sensitivity test. And then they do the CAMP test here. All right, so with the bacitracin sensitivity and the CAMP test, as well as all the other results we've discussed, what species is this? And write that down. Let's briefly go on to case study 3. We have a 32-year-old male construction worker coming to the emergency room with a wound like this. He had a small sliver of wood that penetrated his jeans. I think it was from the day before. Yeah, the earlier the day, or earlier that same day. In a short period of time, the wound site became alarmingly painful, red, and swollen. He's taken into surgery to remove the dying tissue. The surgeon orders a gram stain, and there it is there. Let me blow this up. Once again, they're looking at the cells inside him. They're not subcultured. So these cells are the patient's cells, and those are the bacteria. I can't see what that is. It's probably hemolysis. Yeah. So this is blood agar plates, greatly enlarged to show you the hemolytic activity. So that's the bacteria. That's the hemolysis around it. They then take the cells from the blood agar and do the catalase test. There's the results there. And oops, there's the bacitracin sensitivity test. And there is the CAMP test. Any questions about this case study? If not, let's move on to number 4. A 73-year-old man is admitted to the hospital with pneumonia. He gets a spike in fever, experiences a lack of alertness. They do some blood cultures. And one of the cultures, blood is cloudy. They streak out the bacteria, although that doesn't look like blood. I'm not sure where they got that bacteria, but there's the bacteria there. That must be maybe a lung culture, because that doesn't look like blood. And there's the bacteria there. And they do a few other tests, which you guys can take a look at. And then answer what was the bacteria isolated. Case study 5. A 38-year-old female who was a methamphetamine addiction comes in for major dental work. About a month later, she gets a low-grade fever, malaise, and signs of mitral valve anomaly. Her condition worsens. She's admitted to the hospital. They do a blood culture, and that's blood right there, and there's bacteria in the blood there. And then they take the bacteria and subculture it on blood agar. There's the blood agar hemolytic activity, and they run a bunch of other tests. And then what bacteria was causing this patient's infection? Case study 6. A 4-year-old girl is rushed to the emergency room with abdominal pain. She's rushed into surgery to remove a ruptured appendix. As a complication, she develops some peritonitis. Peritoneal fluid is sent for routine culture, and you can see the fluid is cloudy. There is bacteria in the fluid. They streak it out on blood agar plate and on McConkey's plate, which you'll note there's only one colony on the McConkey's. You can look up what McConkey's does, but this is another test that can help you identify the species. We then do the catalase test and a few other tests. And what is the bacteria causing the little girl's problems or infection? Case study 7. A 57-year-old diabetic female is admitted to the hospital for hip replacement surgery. She had a catheter for 8 days. She starts developing suprapubic discomfort. Her blood pressure is normal. She doesn't have a fever or flank pain. They do a routine urine culture and grow that on blood agar plate. There's the gram stain. There is the growth on the McConkey's. In this case, we don't have anything growing. And they do a few other tests. What is the bacteria causing the infection in the patient? Case study 8. A 29-year-old immunocompromised female that is admitted to the hospital with flu-like symptoms, personality changes, uncoordinated muscle movements, and seizures. Her husband states she attended a wine and cheese tasting charity event a week prior. The attending physician performs a lumbar puncture to rule out meningitis, and there is cloudiness in the lumbar fluid. And there's the bacteria in the lumbar fluid as well as her cells here, the pink cells. They culture it on blood agar plates and do a few other tests. And this one, you have an extra test. It's extra information where they're growing the organism in a semi-solid medium, and the organism takes on a unique umbrella-like appearance. Let me blow that up a little bit. So you did the stab in the semi-solid media, and instead of just growing on the stab or growing away from the stab, on this one it's growing in an umbrella-like appearance. And you can look that up online to see what that might mean, because that is not in this lab module. But it's an extra test for some extra information in case you need it or want it. All right, any question about the case studies? Remember, use the dichotomous key to identify the bacteria in this case study, and only use this dichotomous key for this lab. Do not use it for your unknown project. Do not use it for other labs, because this dichotomous key is specific to this lab and the species in this lab. It's ignoring other species of bacteria. Any question about any of that? All right, I will be here to answer any questions in the lab until 4:30 or until the last student logs out. So go ahead and get started on the lab. And remember, I am here to help you.